All right, here's our video today on time dilation. And in simple terms, it's basically saying this. It's saying that the faster you go, and this may seem strange, but the faster you go, time slows down for you. Of course, we don't notice it in our lives because we really can't get to the speed of light. Can't even get close to it. But there is a formula, and we'll talk about this. And Albert Einstein showed this in his special relativity formula in 1907. And we've proven this with atomic clocks and GPS. So let's look at this. First, let's get a clean page. And let's see, I'll write the formula. Make sure our pen's working. So there's a special formula here, and I'll write it down. We'll talk about what it's doing. So we have the change of time, prime, equals the change of time. And I'll explain all this. Don't worry. Looks complicated, not that complicated. 1 minus v squared over c squared. And c squared is just the speed of light. So the speed of light, c, is 186,000 miles per second. Talking about in miles. That's extremely fast. If you snap your fingers, what light would do is go around the world 7 times. That's how fast it is. And we can make this formula a little more clearer now for us. We'll just put a line there. We can also just say t prime, and I'll explain this again. I'll just put t and the square root of 1 minus v squared, velocity, over the speed of light squared. All right. So let's look at a problem. Let's say we're on a ship. And again, what time dilation does, again, the faster you go, time slows down for you, especially if you're going the speed of light, which we can't do. So let's say you're on a ship and you're moving. Your time will slow down based on someone who's stationary. So let's clear this out and let's do it. So let's say we have our ship here. Make a ship, kind of weird ship. Who knows? Some wings to it. Some special ship. Who knows what it's called? And you're moving. And let's say you're moving at 0.9 the speed of light, which is very fast, right? Remember, we said that light is 186,000 miles per second. If you think about the fastest thing we have right now is the Parker Solar Probe. Parker Solar Probe. And the Parker Solar Probe, if you think about miles per second, it's going 92 miles per second. It's the fastest thing we have. So compare 186,000 miles per second to 92 miles per second. Can't even compare it. But anyway, here we have a ship moving. And so it has its clock. There's its clock ticking, right? Make a little clock over there. Who knows? And then we have a clock on the ground, stationary. So with this speed, this clock should slow down compared to that clock. And how much it does is called the time dilation. All right, so let's put the formula back on. Clear it out again. And let's put the ship back, actually. Who knows? Looks like that, maybe. Maybe make it a little better looking. So here's our ship. What do we call it? We'll call it the X. We'll call it the X30. Who knows? So again, let's put our formula over here. We're saying T prime equals T square root of 1 minus V squared over C squared. So T prime, right here, that is the time of the stationary object. Or we should say on the ground. The time on the ground or on Earth, wherever you are, wherever you're stationary, that's what would T prime be. T will be the time in the ship. Time in the X30. Time in the ship. V is velocity, how fast the ship is going. velocity. And we know c is the speed of light, which we said was 186,000 miles per second. So let's use a formula. Let's say that you're going 0.9 the speed of light. So let's put a little box here, and we'll put our criteria, and we'll change the color, use white. So we say that we're looking for t prime. We want to know what the time is on the ground. So let's say that on your ship, t on the ship, 10 minutes passed. That's the interval that passed. You're going 0.9 the speed of light for 10 minutes. We'll put 10 minutes over there. We have that already. And we're always going to have 1 minus, and we say we're going 0.9 the speed of light. 0.9 c over c, the speed of light, and all that is squared. And from this formula, we'll get an answer, right? So what we can do is we can cancel out the c's. We have 2 c's there. So we're now left with 10 over the square root of 1 minus 0.9 squared. Put a little arrow so we can keep going. And what do you think we'll get then? Well, if we did that, we'll have 10, right? Be 1 minus 0.81, because 0.9 squared is 0.81. And that will give us 10 over the square root of 0.19. Running out of room here. Let's try to make it a little smaller now, which would be 10 over 0.435. And that'll give us our answer. So the person on the ground, if they looked at your ship, the X-30, moving at 0.9, the speed of light, 10 minutes would pass on your ship, but for the observer, it would be 22.9 minutes, roughly around there. So time slowed down by almost 13 minutes. All right, let's try one more. Try it on your own. Let's clear this out. Clear the screen. Go back if you need to. All right, change the screen out. So let's draw our ship. Try to draw our ship anyway, if the pen's working. Get the pen going. All right, so here's our ship. And let's say now, fancy ship. Let's say now that we're going to travel for 2 years. We're going to travel for 1 year and then head back to Earth. So 1 year going to wherever we're going, who knows where we're going, and then 1 year back. And we're traveling, our velocity now is going to be 0.99 the speed of light. Do you remember what the speed of light was? Right? 186,000 miles per second. So when we get back to Earth, going at that speed, what was the time dilation? Is Earth or Mars, wherever we're going. So 1 year out, 1 year back, so it's a total of 2 years. So do you remember the formula? Right, so we can say t prime, that's going to be the time on Earth when we get back. The time that elapsed in our ship, the clock that was on our ship is t, and we're going to put that all over what? You remember? 1 minus what? Velocity squared over c squared. So why don't you try that problem? Pause the tape if you want to. Let's fix that t while I'm doing it. Better t like that. There we go. So what do you think? All right, make a little line here. We'll start over here. Maybe let's use green. See if green works. Does green work? I'll try red. So remember we said t prime is going to be 2 years is t. 2 years have passed since we were in this ship. Right? And so we're going to say the square root of 1 minus, and we're going to say 0.99c, going a little faster, over c, and of course the whole thing is squared. Now remember, use green. The C's will cancel out. So now we say 2 over the square root of 1 minus 0.99 squared. And we'll keep going. So then 2 over the square root of 1 minus 0.9801. I'm going to put an arrow over here. And then we'll have 2 over the square root. And 1 minus 0.9801 will be 0.0199. We got to get the square root of that, which will give us 2 over 0.141. It's actually more numbers, but we're just estimating. So roughly, we could say about 14 years have passed on Earth. So if you were, let's say you were 30 years old, you went out, came back, on your clock it says you're 32 years. It's not the case on Earth, because 2 years passed on Earth, but 14 years passed. 14 years passed on Earth, and only 2 years passed on your ship. So you think you're 32 years old, and if you had a friend who was the same age as you, they would have aged 14 years, and you would have only aged 2. So if you want to get younger, go with the speed of light. All right, that's our video today.